Let's continue looking at types of solutions, but today let's focus on electrolytes and non-electrolytes. So as a reminder, our learning objective is to be able to distinguish among the different types of solutions, such as electrolytes and non-electrolytes, unsaturated, saturated, and supersaturated solutions, and strong and weak acids and bases. Today we're going to focus on electrolytes and non-electrolytes. So the term electrolyte and non-electrolyte is actually used to describe how a solute breaks up in solution. And really we're going to distinguish between whether we're forming ions or not. So electrolyte you might have seen before on bottles such as Powerade or Gatorade or Pedialyte, and they're formulated to be electrolyte water or 4 electrolytes or electrolyte solutions. And that's because all of these drinks have added salts. An electrolyte is a solute that when I put it into water will dissociate, or that is, it breaks apart into ions, into positive and negative charged smaller pieces. So typically when we're looking at electrolyte solutions, we're looking at things that are ionic. That means that they're most often made out of metals and non-metals that have chemically bonded. There is a special type of electrolyte called acids and bases that are covalent molecules with charges, but we'll talk about those later on. And because of these ions in water, electrolyte solutions can conduct electricity. Now, if I put salt in water, what we see happening is that as the water molecules pull the salts apart, now we have these positive and negative charges floating around, and that's what's going to allow the conduction of electricity. A non-electrolyte, by contrast, is a solute that does not contain ions when it dissolves. So the molecules still dissolve, but they stay together and no charges are found in that solution. An example of this might be sugar. Sugar dissolves in water because it is a slightly polar molecule, but the molecule stays together and doesn't have a positive or negative charge on it. Typically, other covalent compounds are going to be non-electrolytes. And because there are no positive negative charges, when I try to apply electricity to the solution, the electricity can't conduct through it. So prior to most people's belief about water being able to conduct electricity, it's actually not the water that's conducting electricity, it's what's in the water that helps it conduct electricity. Pure water on its own can't conduct. So if I want to test a solution to see if it's an electrolyte or a non-electrolyte, we actually do a conductivity test, and we simply set it up so that we have a light connected to a power source, but the light isn't fully completed in the circuit. And so we'll use 2 electrodes separated by some metal plates or something, and we can put them in water and we'll measure to see if the light turns on, or we're going to observe if the light turns on. Here's in the ethanol case, the very first one, we see that the light doesn't turn on. So this isn't conducting electricity, so that tells me that it's a non-electrolyte. The middle one, the KCl, the light does turn on, and this tells me that it is an electrolyte, and that's because potassium and chloride make an ionic compound, and so we have positive and negative charges that end up floating around. And then we have something like acetic acid, which we see the light turn on, and so we would call it an electrolyte, but this is one of those special case ones. Acetic acid is an acid, so it's actually made out of non-metals, and you'll notice that it's not quite as strong of a light being turned on. And later on, we'll talk about the difference between a strong electrolyte and a weak electrolyte. But that's about it for electrolytes and non-electrolytes. Again, to sum it all up, electrolytes dissolve into ions. Another word that we use for this is they dissociate into ions. This means that they can conduct electricity. So a simple conductivity test, we'll see the light bulb turn on. Non-electrolytes do not dissolve it or dissociate into ions. They do dissolve, but because there are no ions, they can't conduct electricity.